Careful everyone, here we are witnessing some brutal interspecies competition. Yes, I know, it's just a vegetable garden, but even here we can see some crazy awesome fights. Here we are For instance, here we're witnessing the tomatoes fighting with the herbs and the peppers for the nourishment in the soil so that they can survive and flourish. Now obviously we can see from this that the tomatoes are pretty much dominating the fight for survival since they're so huge. They're taking up almost all of the resources from the other plants. Now let's just say that because of this huge size, these plants started attracting aphids. Nasty little bugs, ever known them? Depending on how these bugs reproduce and how they begin eating the plants, we could potentially be seeing a mass tomato-cide. Not only that, but along with the tomatoes, the elimination of the other bugs and worms and insects that help the plant grow will also be eliminated. It'd be like War of the Gardens for aphid. And this is an example of competitive exclusion. And this is where two organisms fighting over the same resources cannot stably coexist. Meaning that while the aphids and other bugs fight over who gets to munch on the plants, eventually only one will be able to utilize its resources. Hi, you're just gonna sit there? You know, I'm doing something. I'm shooting. I'm doing stuff. This will leave the other organism to either find a new resource or let it die out entirely. Either way, it's bad for me and other gardeners because the more aphids that come, the more there are to devour the plants. No. Let's say I placed a few ladybugs in the garden. Ah, see, now we're getting somewhere. The ladybugs will march through the plants and start smacking down on those aphids, basically policing them and keeping their numbers in check. Plus, they're pretty. And so it shall be that the tomatoes are once again safe. Yay! And this whole process of adding these ladybugs to the tomato plants so that the aphids don't throw the balance off is something scientists call Trophic Cascade. Isn't that right, buddy? Yes, it is. Yes, it is. Hey! Sick of my face yet? Trophic Cascade is a phenomenon that says when you add or remove a top predator from an environment, it will impact the ecosystem as well as alter the behavior of the organisms in it. Now I know when you think of predators, you're probably thinking of something more along the lines of a lion or a grizzly bear or something along those lines with big teeth and claws, and not some little ladybug that's buzzing around your front lawn. But a ferocious lion prowling the Serengeti and a ladybug crawling across the leaf aren't all that different. You see, predation isn't just limited to the carnivores of our world. In fact, it's much, much broader. Predation is basically just one organism killing another to consume its energy. And this is important in ecology because a lot of it has to do with watching that flow of energy in nature. And of course, everything needs that energy to complete the ultimate goal of surviving and making lots of babies. Since almost all energy in the world starts with plants, we can assume that cattle eating grass and fish munching on algae are types of predation, specifically herbivory. See? There are lots of things that can be classified as a predator, even that teeny tiny little aphid. Ah, you see what I did there? I brought it full circle. But trophic cascades, while seemingly simple, can have very complicated outcomes. Taking even one organism out of the equation in any ecosystem can have tremendous effects on the environment. And the same goes for adding one. Everything in an Why can't I speak? Everything in an ecosystem has a role to play, so when you take away or mess with even just one piece of it, everything else has to shift and morph to make the change work. And that's not to say that it always does. Some environments can't handle the change and eventually just die out. But other times, changes aren't only immense, but mind-boggling. Take for instance the wolves that were reintroduced into Yellowstone National Park in 1995. Some of the more obvious changes quickly happened, such as their prey starting to go down in numbers. But what scientists noticed after watching this environment was that the wolves began changing things that weren't even seemingly related. See, what happened, and what scientists witnessed, was that the wolves' presence in the environment actually changed the flow of the rivers. I know I just blew your mind, so I'll give you a moment to recollect it. Moment's over. Moving on. So after the wolves were pretty much wiped out of Yellowstone due to all the hunting, it started taking its toll on the land. With nothing left to fear, deer populations began to rise, and they did what deer do. They ate. And they ate a lot. In fact, they ate so much that Why can't I say the sentence? In fact, they eat so much that despite the efforts of even us as humans, they still manage to graze away pretty much all the vegetation in the park. So when the wolves came in, they, of course, started eating some of the deer, but not only that, they changed the behavior of the deer, specifically where they grazed. They began avoiding certain valleys and plains where they could be easily trapped. And so when they left, the vegetation started growing back and trees started to grow. And the beavers started to come to eat the wood And because of that, the birds started coming back. And the beavers started to chew down the trees and build dams, which made habitats for ducks and fish and otters and other animals. Other predators started to come and feed off of the carcasses, the carrion that the wolves left. The wolves also started killing the coyotes, and so that made the population of rabbits and mice and other small creatures start to boom. And in turn, this brought in hawks and foxes and other predators that eat these critters. And all of this led to the change in the rivers, the change of the water. And this happened because the regenerating vegetation began to stabilize the banks. It caused them to collapse less. It gave way to less soil erosion. The wolves actually changed the flow of the rivers. I'm getting goosebumps. There are people outside, and they're being loud. The person generally credited for describing the mechanisms of Trophic Cascades in Yellowstone is one Aldo Leopold. And though he's credited for this, the ones that actually are credited for introducing the concept to scientific discourse are, wait for it, Nelson Hairston, Frederick E. Smith, and Lawrence B. Slobodkin. Not a fun name, Slobodkin. These men argued how predators reduce the number of herbivores and allow plants to flourish. This is often referred to as the Greenwald hypothesis. And this hypothesis is important because it shows how things such as predation can have an indirect effect on shaping the ecological communities. Hairston, Smith, and Slobodkin argued that ecological communities acted as food chains with 3 trophic levels. And to further this, models were created that contained both more than and less than 3. These trophic levels can be broken down into about 5 different categories, some of which can be excluded depending on the environment. 1. Plants and algae that make food through a process called photosynthesis are called primary producers. 2. The organisms that eat the plants are called primary consumers. 3. The carnivores that eat the herbivores are secondary consumers. 4. The carnivores that eat the other carnivores are tertiary consumers. This reminds me of Woodstock from the Peanuts cartoons. I don't know why. 5. And then there are the apex predators that have nothing hunting them and pretty much eat everything. Go humanity! Also categories such as decomposers or the detritivores, who break down and eat the leftover plant and animal waste that everyone else leaves for energy. But that's another story. While the existence of trophic cascades isn't debatable, it happens anywhere. It's not controversial. It is, however, argued how ubiquitous they are, and this just means how often they occur in an ecosystem. Hairston, Smith, and Slobodkin argued that terrestrial ecosystems behave as a 3 trophic level trophic cascade, and this just created a whole hullabaloo. Since there can be other determining factors on whether or not a consumer will get to consume, it sparked controversy. For instance, not all predators keep herbivores from eating plants. In fact, some vegetation has evolved to grow its own protection, such as thorns. Other limiting factors can also come into play that determines whether an organism will survive or not, and it just goes to show how trophic cascades aren't all neat and clean like most scientists would like. There are many factors that go into it, not just 3 main trophic levels, and this principle is sometimes known as the trophic trickle. Sounds like a weird dance, doesn't it? Huh. So the next time you go outside and consider killing off all those weeds in your lawn, just think, you could be creating a whole trophic cascade that could alter your entire backyard ecosystem. And that is pretty cool. Thank you very much for watching. I really hoped you learned something. And if you did, well, congrats! You get to go to sleep because you learned something new. So once again, thank you for watching, and I hope you all have a lovely day. Bye-bye!